Okay, so previously you guys had talked about multiplying and dividing these rational expressions. We're going to get into adding and subtracting now, which works a little bit differently because if you guys thought, think back to what you guys were doing in section 2. When you were multiplying and dividing, did you need to have a common denominator when you were doing that? No? When you multiply and divide fractions, you do not need to have a common denominator. Do you need to have common denominators though when you're adding and subtracting fractions? Yeah. If they both have to be over a 3 or over a 5 or whatever the number is, they have to be the same before we can add and subtract them. So we're going to get into adding and subtracting today. The difference is that we're going to have to find common denominators for some of them. Not for all, but for some. Remember when you add or subtract fractions as well, once you have the common denominator, you don't actually do anything to the denominator. You don't add or subtract those pieces, you just leave them alone. So all the operations then kind of happen on the top. So just kind of going back to a really basic example with just numbers. We have 2 sevenths plus 8 sevenths. They're both already over a 7. Okay, so they already have a common denominator. So we're going to go ahead and just add the numbers on top and leave it over 7. You're not going to do anything with that 7. So what's 2 plus 8? 10. So we're going to leave this as 10 over 7. You don't have to change that so that it's proper, like write it as a mixed number. I don't care about that. I just want to see you guys adding these together. So you guys take a look at number 2. Do these fractions have common denominators? Yes. That b minus 2 is common. So we're going to leave this over b minus 2. What am I going to do on the top? A minus b. There's really nothing that I can do with that as far as like combining a and b because I don't know what a and b are. So I'm just going to leave them as that one sentence, a minus b. And then it's all over b minus 2. Okay? So why don't you guys take a look at number 3. Try to combine it, and then if you think you can reduce it at all, try to reduce it as well. So we have that common denominator, 3x. What does the top become? 12. Because 6 minus 2 would be 4, plus 8 is 12. Is there anything I can reduce here? And what else? The 3. What can you take out of both 12 and 3? 3. Or you can think of like, what would be 12 divided by 3? 4. So this becomes a 1, this becomes a 4. So if I'm going to simplify it one step further, it'd be 4 over x. Okay, let's take a look at number 4. So again, I already have my common denominators. It says a plus b on the bottom. I'm going to have to just combine the top pieces, and we're adding it together. So if you combine the top, what is it going to say? Okay, because a plus a is going to be 2a. Negative 3b plus 5b is going to be 2b. Now looking at just the top portion, so just the 2a plus the 2b, do they have anything in common that I could maybe factor out? A 2? So if I factor out a 2, I'm left with a plus b. Do you agree with me? And this is still all over a plus b. So think back to what you guys were doing with multiplying and dividing when it came to like simplifying things. Is there anything that I could reduce here? So the a plus b's, you have one on top, you have one on the bottom. So I can go ahead and think of them as canceling each other out. Or if I were to divide them, they become like a 1. What am I left with here then for an answer? 2. So for a lot of these problems, you're going to have to combine the numerators, put it over that denominator, and then see if there's any simplifying you guys can do. And that involves like taking out numbers. It could even be taking out letters. And then if you see those quantities that are the same, you can reduce them just like you guys were doing with the multiplying and dividing problems. Okay, so turn the page over. I want you guys to go ahead and try number 5. Let's go ahead and just combine the top. What would be 2x squared plus x squared? 5x plus negative 19x. Negative what? 14. Negative 9 plus 4? Negative 5. Okay, on the top there, we would try to factor it if we can. Now, this one, as far as factoring goes, it doesn't have just x squared, so I can't just split it easily. These are the ones that you have to do a little bit more work with. So there are a couple options. You could either try to factor it, okay, by doing like your A times your C method, and then rewriting the middle term, factor them by grouping. We did that back in chapter 2, which was a while ago. You could use the quadratic formula to find your two solutions, but you would have to be able to write them as factors. Okay, or you can also think of this as a division problem because fractions mean division. So if I tried to like do long division or even synthetic division to find the other factor, I could think about what that would be on top then. So doing one of those methods, on the top, when I factor it, I'm going to have 3x plus 1 and then x minus 5. This is going to be all over an x minus 5. So then I can get rid of the x minus 5s. Because again, I have one on top, one on the bottom. And so I'm going to be left with 3x plus 1. So far, I've only shown you problems, though, that already had common denominators. Okay, we didn't have to do anything to the bottom of the fraction. They already matched. Now we have to get into the situation where they don't match. Okay, so if you have unlike fractions, you have to make them look like each other first before you can try and add or subtract them. So to do that, we need to talk about something called the least common denominator, LCD. This is when you're looking at the numbers that are in the bottom or like the terms that you have in the bottom of your fractions and you're trying to get them to match. But you want to use or get to like the smallest number that they have in common. So in order to do this, you want to factor all of your denominators. So if it can be factored, you want to start there first. Figure out then what the common denominator is. So everything about them has to match. So if one of them has an x squared and the other one doesn't have an x squared, we have to somehow get the other one to have that x squared. If you just need to get the numbers to match, then just get the numbers to match. Okay, then what you're going to do is multiply the fractions by whatever needs to be multiplied by to get those fractions to match. And then go ahead and simplify. Now we're going to start again with just a numbers example to kind of refresh your guys' memory on how you've done this in the past. When you guys were first learning about fractions, which I know was a long time ago, Okay, you guys had to do this, where you had to add and subtract unlike fractions. So I have 1/3 plus 2/5. What's the least common denominator? Good, 15 you said? So tell me then, how do you guys get 1/3 to have 15 on the bottom? Good. What do we have to do to the second fraction then? Good. Take that first fraction times 5, take the second fraction times 3. So now it's going to say 5/15 for that first fraction plus 6/15. Now they have common denominators, so if I add them, what's my final answer going to say? Okay, so let me show you some cases now where we have letters and those kinds of expressions in our problem. It's not just regular numbers like that. So take a look at number 2 here. I have 16 over x squared minus 16, and then plus 2 over x plus 4. Remember, up above when I gave you guys the steps for finding LCD, the first step was to factor all denominators. So I want to factor the left one, because it says x squared minus 16. So I'm focusing on this one for right now. I'm not going to do anything to the second fraction. For that first one, this is called a difference of two squares type of problem when we're coming to factor. You probably learned about how to factor this back in algebra, okay? And I only know that because we just taught our algebra kids how to do this. We talked about some of these factoring rules in the last chapter with them. So when you're looking at x squared minus 16, you're going to want to put it into parentheses like this. Okay, x squared, you can drop an x into each set. 16, what would be the square root of 16? Okay, so we also get a 4. Now if I look at my term over here though, it said x squared minus 16, so it was missing the middle term. Like there's no regular x term. And that's because when I multiply these on the bottom, one of them has a plus sign and the other one has a minus sign. So the middle terms end up being opposite and they cancel each other out and they're gone. And so if I actually FOILed this, it would say x squared minus 16. But the reason why we factor it is because now if you guys look at the second fraction that we have there, what is the second fraction missing from its denominator that the first one has? Good, x minus 4. So what I need to do is take the second fraction, and only the second fraction, times x minus 4. So for now, I'm going to leave the first one alone. And I'm going to change the second one a little bit. I'm going to, on the top, have to distribute this 2. 2 times x, 2 times that minus 4. So it's going to say 2x minus 8. And now the bottom should look the same. It should say x plus 4, x minus 4. Now I have common denominators, so I should be able to add these expressions together. And again, when we start adding, we don't do anything to the bottom. What's my new numerator going to say? So 2x plus 8. 16 minus 8 is going to be positive 8. Now, on the top, is there anything that I could factor out of that expression, 2x plus 8? 2? What would it say if I took a 2 out? Right, x plus 4. And this is still over x plus 4, x minus 4. Good, so these x plus 4s are going to cancel. What am I left with on top? 2, and then we have x minus 4 on the bottom. So once you have those common denominators, simplify your numerator by adding or subtracting the terms together. Factor out, simplify if you can. And that's when you guys go back to those rules that you talked about when you were multiplying and dividing, where you get rid of anything that they have in common. Okay, any of those factors. And that's why we're factoring out the expressions, is so that I can eventually eliminate them. All right, let's look at number 3. This is a little less complicated because it's just numbers. 4 and 8. What's the least common denominator here? 8. So which fraction do we need to work with? The first one? What do I need to do to it? Okay, we're not going to do anything to that second fraction. So what does the new fraction say on the left side? 4n. Good. Good. And then plus n over 8. Okay, all we did here is we distribute that 2 to the 5 and to the 2 in there. Okay, if you combine the top, what's the top say now? What should you do next? What's that? Yeah, so on the top, is there anything that you can take out of 5, n, and 10? 5. What would be left? Okay, n plus 2 over 8. Now, I'm kind of stuck here that I can't reduce the 5 and the 8. I can't get n plus 2 to cancel out with anything. So there's really nothing else I can do there except box it up and call it my answer. Okay, why don't you guys try number 4? That's the last one there on that page. So what's your least common denominator here? What's a number that both 8 and 12 could go into? 24. And we also need an a, which they both already have an a, correct? So really all we need to do is worry about the numbers here. So for that first fraction, 7 over 8a, what are we going to do to it? Yeah, take it times 3. What are we going to do to the second one? Okay, take it times 2. What's the new first fraction going to say? And the second fraction? So what's your answer say?